Hello everyone. Today, we will prove a number theory result that the cube of an integer must take one of only three possible forms, namely 9k, 9k plus 1, or 9k plus 8. We will use the division algorithm as our main tool to uncover this hidden structure within all integers. According to the division algorithm, for any integer n, we can write it as n is equal to 3q plus r, where q is an integer and r is the remainder when n is divided by 3. So since the remainder can only be 0, 1, or 2, we will examine each of these three values of r separately. So namely, n will be equal to 3q, or n equal to 3q plus 1, or n is equal to 3q plus 2. For the first case, let r equal 0. That means n is equal to 3q. So first, we must cube both sides. That will give us n cubed is equal to the quantity of 3q cubed. Now, by cubing 3q cubed, we will get n cubed is equal to 27q cubed. Now, by factoring out 9 from that expression, we will have n cubed is equal to 9 times the quantity of 3q cubed. Notice that this is exactly a multiple of 9. Hence, in this case, let k is equal to 3q cubed, then n cubed will be equal to 9k. So if n is equal to 3q, its cube is exactly a multiple of 9. Now let us proceed to case 2. So in the second case, r is equal to 1. Therefore, n will be equal to 3q plus 1. So in order to get the cube of n is equal to 3q plus 1, we must first expand the cube. So the formula is the quantity of a plus b cubed is equal to a cubed plus 3a squared times b plus 3a times b squared plus b cubed, where a is equal to 3q and b is equal to 1. The next step is for us to substitute a and b of their respective values. So by substituting a and b, we will get the quantity of 3q plus 1 cubed is equal to the quantity of 3q cubed plus 3 times the quantity of 3q squared times 1 plus 3 times the quantity of 3q times 1 squared and plus 1 cubed. Following that, we will simplify the quantity of 3q plus 1 cubed. So it will be 27q cubed plus 27q squared plus 9q plus 1. Now, since the first three terms are multiples of 9, we can factor out 9. So it will become 9 times the quantity of 3q cubed plus 3q squared plus q and plus 1. Hence, in this case, let k be equal to 3q cubed plus 3q squared plus q, which will be an integer, then n cubed will be equal to 9k plus 1. So, if n is equal to 3q plus 1, its cube is always 1 more than a multiple of 9. The final case is case 3. So, in this case, r will be equal to 2. Therefore, n will be equal to 3q plus 2. So, same process as case 2, we must expand the cube. So using the formula, quantity of a plus b cubed is equal to a cubed plus 3a squared times b plus 3a times b squared plus b cubed. However, in this case, a will be equal to 3q and b will be equal to 2. So we must substitute the values of a and b in their respective values. So it will become the quantity of 3q plus 2 cubed equals the quantity of 3q cubed plus 3 times the quantity of 3q squared times 2 plus 3 times the quantity of 3q times 2 squared plus 2 cubed. Next is by simplifying the quantity of 3q plus 2 cubed, we will get 27q cubed plus 27q squared times 2 plus 9q times 4 plus 8. We will then have 27q cubed plus 54q squared plus 36q plus 8. Notice that the same as in case 2, the first three terms are multiples of 9. Therefore, we can also factor out 9 from these three terms. This will make the quantity of 3q plus 1 cube equal to 9 times the quantity of 3q cubed plus 6q squared plus 4q then plus 8. Hence, in this case, let k be equal to 3q cubed plus 6q squared plus 4q, which is an integer. Then n cubed will be equal to 9k plus 8. So, if n is equal to 3q plus 2, its cube is always 8 more than a multiple of 9. So, after reviewing all those cases, we can now come up with a conclusion. So, our conclusion will be that every integer n must fall into exactly one of the three cases, which are r is equal to 0, 1, or 2. Therefore, every integer cube can only take one of three forms: 9k, 9k plus 1, or 9k plus 8. These results show that no cube of an integer will ever leave any other remainder when divided by 9. So, that will be our conclusion. Thank you for listening, and I hope that now you know that the cube of any integer has the form of 9k, 9k plus 1, or 9k plus 8 using the division algorithm.